Okay, guys, so we'll look into this question, and this is a good one. Okay, this basically is a very interesting question based on the proportionalities of boats and streams, or time, speed, distance, you can say. So what I will do is, I'll read it out once. On a river, B is equidistant and intermediate to A and C. So let me just try to draw a figure, something like this. Okay, so and it is written that let me just, we know that these two distances AB and BC are same. Okay, now whether they have an implication or not, we'll know. Now it is saying that if a boat can go from A to B in 6 hours and from A to C in 7 hours, okay, see, A to B and back, what does this mean? So basically we all know that whenever we are looking into a boats and stream question, B plus R and B minus R is always there. This is a downstream condition and this is a upstream condition. Now obviously upstream, downstream, basically we all know what upstream, downstream is. However, what I am more interested in knowing is the same boat goes from A to D, A to B, and the same boat goes from A to C also. And we know that the speeds are all uniform, and I also know that the speed of the river is also uniform. So the thing about the boat going from A to C in 7 hours can be considered as one of the component of the, either it can be a downstream or a upstream. Now because you know the boat is traveling from A to B and then going from B to C and then coming back from C to B and then B to A, I am assuming that I am taking the component of downstream. Now if it has to be the component of the downstream, what I can straight away assume or rather deduce is that 7 hours it takes to go downstream from A to C, which is 2x distance, Okay, total distance is 2x, right? So how much time will it take to go half of the distance? Obviously, because the distance is constant. Okay, so if I assume that the distance is constant, okay, so it will be a little illogical to say constant and all. What I would rather say is, because I know that one part of my distance is covered in 7 hours, half of that should be covered in 3.5 hours, right? And how does this happen? Obviously this is proportionality. It has got nothing to do with the distance as such. It is just that if the entire distance is of 2x and it has been covered in 7 hours, how much half of that will be covered in? So that is definitely half of the time that has been there, right? So this is an analogy, 3.5 hours. Now hold on, the question says it A to B and back in 6 hours. Okay, so the boat can go from A to B and back in 6 hours. Now which component of that overall 6 hours, which component of that is this 3.5 hours? Obviously the downstream component, right? An upstream component I don't know. Now I will know. The upstream component of that will be 6 minus 3.5, which is 2.5. Okay, just a second, hold on. 2.5. Now if this is the upstream component from A to B, the upstream component from A to C will be, obviously the distance is 2 times of that, so the ups will also be 2 times of this 2.5, which is 5 hours. Okay, thank you.